Hey guys, and welcome. In this video I'm going to talk about how we can import or export data to or from the ABAQUS using the UEXTERNALDB subroutine. Here's an example showing how we can use that subroutine. Suppose we have an object which is meshed according to this picture, and we are going to assume that each element is going to have its own strengths or Young modulus, etc. I'm assuming that we supplied those information in an IMP file or in a .dat file or in a txt file, and we just want to import those data to ABAQUS. Here's the required commands. First, we are going to open that particular data file. For example, here I have a file which is saved in c/users/txt1.dat, and I'm going to assign a number to that file. From here on, I'm going to refer to this file as number 15. And we are going to use status unknown, which indicates that the file is already exist in the directory or not. ABAQUS uses unknown keyword for better performing. And we are going to use the formatted form. This is a pretty important point to remember. We are not going to use the unformatted keyword because ABAQUS thinks that we have a binary data, and we are going to use iostat to see is there any problems regarding opening the data file or not. After we open the particular file, we are going to read line by line from that file. I used the 15 number to indicate the file, and here star to make ABAQUS or exactly make my compiler to read any kind of information. And I'm going to use iostat keyword to show that I have any problems or not. And we are going to use the previous commands in UEXTERNALDB subroutine. This subroutine is pretty straightforward, and it has one particular item that we should remember. So UEXTERNALDB subroutine is called once each at the beginning of the analysis or increment or step, etc. And we are going to control this reading by a keyword. Also, it can be used to open external files, as we are going to see, and read history information or write the history information. So here's the most important keyword in UEXTERNALDB subroutine, which is LOP, an integer indicating when to open, read, etc. a file. For instance, we want to just read, or I better say import data at the start of the analysis. This is because we are not going to use any kind of memory at each increment, and if our analysis is going to have many increments, every time ABAQUS reads that file is going to allocate some memory to it. So we are going to make ABAQUS with LOP equal to 0 to only read that file at the start of the analysis, or we can use LOP1 to make ABAQUS read the file at every step, start of every step, or LOP2 to read the file or write the file at the start of every increment, and etc. Now I'm going to show how we can import data for that particular problem that I showed before. Continuing with the subroutine, first I will show my .dat file. Here I've supplied the strings of my elements according to their coordination. For example, if we see this image, we can see that elements 1, 2, 3, 4, 5 are in the same direction, and 6, 7, 8, 9, 10 are in the same direction. And I was using the Z direction for indication. So first 1, 2, 3, 4, 5 elements having the first column here, and the second part of the elements which is 6, 7, 8, 9, 10 elements are going to have strings according to the second column. So when I'm going to use my UEXTERNALDB subroutine, first I'm going to assign an matrix for this particular data, which is going to be a 5 by 2 matrix, as we can see it here. And then I'm going to reshape this matrix into a 1 by 10 element. This is because ABAQUS passes the UMAT subroutine or any kind of subroutine the element number. So if I have for example 100 elements, it is easier to supply a matrix for example 1 by 100 to easier read import the data. And if I'm going to use this random sigma 2 matrices in other subroutines, I must build a common block and save this data into these matrices, which is going to be the common block named matrix. Next, I'm going to use the LOP equals 0 to make ABAQUS only read the input data at the start of the analysis. So I'm going to use the open command with the number 15 for my particular file. ABAQUS uses 15, 94, 96, 98 in its examples. I'm going to use the same numbering, it doesn't matter. The most important keyword here is IOStat, which is going to show us how the operation system have read the file. For example, if IOStat becomes 0, then there were no problems reading the file. And for instance, if the IOStat becomes, for example, number 29, then the Windows is going to run into problems reading the file. And I'm going to save that number into error keyword, which is an integer. If error keyword is going to be 0 here, I'm going to read the data from my IMP file or .dat file into the random sigma matrix. Here's a pretty important note. Fortran 77 reads data line by line. So here I have 5 lines. For that purpose, I must use 5 read lines or a do loop with the number 1 to 5 to make Fortran read the data line by line. And if we are going to run into a problem using an if condition, I will see the problem and I'm going to solve the problem. Next, I'm going to use close 15 to close the open file. Now, what I'm going to do is to reshape the random sigma into random sigma 2. For that purpose, I'm going to use the reshape function, which is going to be on this format. So, as you can see, the reshape function is going to reshape the random sigma matrix, which is 5 by 2, into the random sigma 2, which is going to be 1 by 10. Now I'm going to use the path given by Windows to make ABAQUS read my file. Remember, ABAQUS uses 2 slashes for the addresses. Now I'm going to use these lines to make the random sigma and random sigma to a global matrix. I'm going to copy these, and for example, if I'm going to have a UMAT subroutine, I'm going to copy those data into these lines. Next, to see my input data used, I'm going to save this data into random sigma 2 in my UMAT subroutine and use them as the state V's. So here I have 10 elements or 10 meshes, so I'm going to have 10 number of elements. ABAQUS passes the number of elements to UMAT, and UMAT is going to read those data by random sigma 2 matrix and assign them to xfx parameter. I'm going to use the state V to show my data. So if we submit the job, we can see that the data is being used for the STV1 parameter, and it's going to have this data. This concludes our video. If you find this video useful, please support me by subscribing and liking my videos. Thank you.